Hello, this is Krutoo and today we are going to do some problem from paper 3 IAL 2020 June math. I chose number 8 for this demonstration because in paper 3 there are usually 10 questions or so, and relatively the difficulty will increase towards the end. So question number 8 is considered a little bit on the harder side, if you can say. So this question is split into 3 parts, and you can see that it's 2 points, 3 points, and 4 points relatively. So we'll look at the first one first, and this is the cutoff point. We don't need any information below this point to do the first question. The question said that the curve C has an equation of y equals gx, where gx is e raised to the power 3x secant 2x, where x is limited within negative pi over 4 and pi over 4, and that's if anyone wants to understand it in degree, that's negative 45 degree to 45 degree, but that's not important for now. So the first one asks us to find the first differentiation of gx. So I'll take this to another page since we are running out of space. Okay, so since this question, if anyone forgot, is 2 points, it will not be that complicated because it just asks you to simply differentiate this function, and in order to differentiate this function you only need one thing, actually two. It's a product rule. And within these functions that you are applying the product rule, you also need to know chain rule, right? Okay, so in order to product rule, you probably at this point know that product rule is u times differentiation of v plus v times the differentiation of u. So we have to pick our u to be, I'm going to pick this to be e raised to the power of 3x. Therefore the differentiation of u is going to be 3e 3x because of chain rule, and v is going to be sec of 2x, and therefore the differentiation of v is going to be, well, if you differentiate sec you get secant, right? So it's going to be sec of 2x tan of 2x, and since this is function inside of a function, we have to apply chain rule to this. So you also have to multiply it with the differentiation of 2x, which is just 2. So now the differentiation of gx would be u times dv, which is e to the 3x times this whole thing, which is 2 sec 2x tan 2x, and then you add it with v, which is sec 2x multiplying with differentiation of u, which is 3e to the 3x. So we can do a little bit of rearranging so that things can look a bit prettier. So I'm going to take 2 in front from this term, and then e to the 3x, and then I have sec 2x tan 2x. Actually, I think I have a little bit of extra bracket over here I'm going to take out. Okay, and then for this term it is going to be 3e to the 3x sec 2x, and that is the answer for the first question. So now we are done with the first question 1a. We'll go back and look at the question 1b, and in order to do question 1b you only need this much information upward. Okay, so they ask you to find the x coordinate of the stationary point of C. Notice that they say stationary point singular, therefore this kind of implies that there is only one point, but do not always trust the grammar of A level, but it's kind of a big hint right here. Anyway, in order to find stationary point, what the question means is stationary point is either minimum, maximum, or the point of inflection, right? Minimum, that's maximum, that's minimum, and that's point of inflection. Not the prettiest drawing, but I think you get the point. The property of min, max, and inflection is that at these points, the gradient or slope are all 0. Therefore, we can take the answer, which is the differentiation of gx that we got from the first question, and then work from that. So let me capture this thing and then bring it to the new page. Also, let me take the whole thing here. Actually, no. Okay, never mind. We have to find the min-max anyway. So in order to find the minimum and maximum, we have to equate the whole thing to 0 to find min and max. And this is question not 2. It's 1A, B, sorry, 1B. Okay, so this whole thing, we can rearrange it a little bit. So you can kind of notice that both terms has a common term of 2 raised to the 3x right there, and it also has the sec 2x, which means that we can factorize these two terms up front, and then the rest will remains in there like that. Okay, so you can see that there are two things multiplying and get you 0. So there are ways to solve this. So you have to imagine each term, can they individually turn into 0? I mean, if you look at the left hand term, you know that e raised to the power something can never be 0 anyway, so we just ignore this term. Now we focus on secant of 2x. The thing is, secant of 2x is 1 over cos of 2x, and in order to get this to become 0, cosine of 2x needs to turn into either something close to negative infinity or infinity, and you know that cosine 2x cannot do that, so you can just forget about this term. This will not work. This will not turn into 0. So we focus on this instead, and this is a lot simpler to do. So we can just rearrange things. So you know that 2 tan 2x plus 3 will equal 0. So tan 2x with a little bit of algebra, it's going to be negative 3, and then you divide it by 2. So you can just press this into your calculator. Inverse tan of 2x. Please be noted that I'm going to do this in degree first, but let me negative 1.5. Okay, so the angle that we get is negative 56.31 degree. So people who are pretty used to ASTC diagram will know that this is going to lie within the 4th quadrant. So tan will not only have a negative in the 4th quadrant, but also the 2nd quadrant, which I can get by adding 180 degree to this, and that will get me 123.69 degree. And also for the sake of it, I'll just add 360 to this one to get another angle. So negative 56.31 plus 360. That's going to get me 303.69. Okay, but please do not forget that we are dealing with an angle within plus or minus 45 degree. So if you look at this, and you will notice that 2x will have to become x. Therefore, we have to divide each answer by 2, right? Which will get us here. Okay, don't forget that we are aiming for answer within negative 45 to 45 degree, right? So this one looks okay. This one, I don't think it will be within 45 degrees, so we'll scrap it. This one is nowhere near close. So our only answer in degree for now will be 56.31 divided by 2, which is around 28.155 degree. And if I convert this into radian, because they expect the answer to be in radian, I have to divide the answer by 180 and then multiply it by pi, and that'll get me to negative 0.491, and that is the answer for this one. Now we are down to the last question, which says a different curve has an equation of x equals ln sine y, where y is between 0 and pi over 2. They need you to show that. So this is kind of a show that question. They need you to show that dy by dx will equal to e raised to the power of x over fx, where fx is a function of e to the x that should be found. Okay, so let's get this problem to a new page. This is sometimes, I can't say that it's unusual, but this part of the question is totally separated from the first part. Usually this kind of continuing question will take information from the previous part and then make use of it, but this one just start from scratch. Okay, anyway, in this question you need to know how to implicit differentiation. You need to know how to do implicit differentiation. Okay, so there are many ways you can do this. First, you can implicitly differentiate from this form, or you can rearrange it a little bit and then implicitly differentiate it. Okay, since this is kind of a chain rule, I'm going to rearrange it a little bit. So if ln of sine y is x, then in the property of logarithm, you kind of know that then e raised to the power of x will equal sine y, and then we can differentiate from this point. Okay, I can say that I differentiate de to the x with respect to x will equal to differentiation of sine y with respect to x, and when I do that, you will see that the left hand side will remain e to the x, but the right hand side, now you have to implicitly differentiate. So when you differentiate sine y, you get cosine of y, and since this is kind of a chain rule applied here, you also have to differentiate y inside, which gets you dy by dx. So if I move cosine y to the other side, I'll get e to the x over cosine of y, and that's going to equal to dy by dx. Okay, now we are in this form already, but we are not done yet because cosine of y is nowhere a function of x. So we have to kind of turn cosine of y into something that's recognizable as a function of x in the form of ex somehow. Okay, so let's take a side note here. You probably know that sine square y plus cosine square y is going to be 1, and that's one of the trigonometric identity that you already knew from P3, right? So if I do a little bit of rearrange, I'll get cosine of y equals 1 minus sine square y, and then I take a square root and then plus minus, right? But since y only exists in the first quadrant right here, I kind of don't have to consider that it could be a negative, so I can just forget about that in this case, and that's why this domain of y is important in this question. So since cosine y is 1 minus sine square y, we kind of know that sine y is e to the x from here. So I can come back here and replace sine square y with e to the x, like that. So cosine y will be 1 minus e to the 2x. And then I can go here and then say that dy by dx is e raised to the power of x divided by cosine y, but we replace it with this thing, 1 minus e to the 2x, and then we are done. We have ourselves the completed answer with this form being the fx that they want in the question, and then we are done. 4 points.